The provided bar graph illustrates the digital wellness index for teenagers aged 14 to 17, comparing habits on Monday versus Saturday. Entertainment screen time surges on Saturday to 6.5 hours, while educational screen time drops significantly from 4.0 hours to just 1.5 hours. Sleep duration and in-person socializing both peak on Saturday, reaching 9.0 hours and 4.5 hours respectively. Physical activity and outdoor exploration also see a notable increase during the weekend compared to the weekday.
The graph illustrates global technology adoption and impact from 2020 to 2030. It tracks two metrics: the adoption rate, blue line, and digital economy growth in trillions, green line. Adoption starts at 18% in 2020 and is projected to reach 88% ubiquity by 2030. The economic impact shows a steady climb from $4.1 trillion to $22.5 trillion. Overall, the data suggests a strong positive correlation between emerging tech integration and global economic value.
There are 5 developmental stages of a hen, starting from an egg. The cycle begins with a 21-day incubation period, leading to the hatching of a chick. It then progresses through the juvenile and mature laying phases, where egg production peaks at 250 to 300 eggs annually. The final stage shows the senior hen phase, marked by reduced laying and molting. Overall, the diagram provides a clear overview of the biological milestones from birth to retirement.
The provided pie chart illustrates the global sustainability investment portfolio for the 2025 fiscal year. The largest share of investment is allocated to the renewable energy grid at 32%. This is followed by sustainable agriculture and food systems at 21% and circular economy at 15%. Green mobility, tech and water infrastructure account for 18% and 9% respectively. The smallest portion is dedicated to biodiversity conservation at only 5%.
The provided infographic details a biomimetic solar seawater refinery, illustrating a 5-step sustainable desalination process. The system begins with passive marine-friendly filtration using a sub-seabed intake to protect local aquatic life. Seawater then undergoes graphene-based molecular sieving, where single layers of carbon filter out salt ions at a molecular level. A water forest uses solar thermal evaporation through carbon nanotube leaves to create condensation and fresh water. The process includes mineral rebalancing and brine upcycling to extract valuable materials like lithium, potassium, and gourmet salt.
The graph illustrates the growth of 4 scientific sectors: physics, biomedicine, green energy, and AI. Fundamental physics shows the highest impact index, projected to reach nearly 100 by 2030. Biomedical science experienced a significant jump between 2021 and 2022 following a genomics breakthrough. Green energy and AI sectors show a more gradual but steady upward trend throughout the decade. In conclusion, the data predicts a continuous rise in global scientific impact across all featured technological fields.
The provided donut chart illustrates global primary energy consumption by fuel source for the year 2023, measured in exajoules. Oil is the primary energy source, accounting for the largest share at 33% or 184 EJ. This is followed by coal at 27% and natural gas at 24%, showing a heavy reliance on fossil fuels. Renewables, including hydro, wind, and solar, contribute 12% to the global total. Nuclear energy represents the smallest portion of the portfolio at just 4%.
This bar graph provides a clear overview of global renewable energy capacity by source for the year 2023. Here is a natural, spoken-style description. The graph compares 5 renewable energy sources, with hydro being the largest at 1393 GW. Solar follows closely as the second highest source, contributing 1185 GW to the global capacity. Wind energy holds a significant middle position with an installed capacity of 906 GW. Bioenergy and geothermal represent the smallest shares, at 172 GW and 16 GW respectively. In conclusion, while hydro remains the dominant source, the note indicates that solar is the fastest growing sector.
The provided image depicts a highly stylized, fantasy-inspired world map featuring vibrant artistic details. The map showcases a unique aesthetic with intricate patterns representing various regions, including sub-Saharan Africa, East Asia, and the polar areas. Mythical elements are present throughout, such as dragons, a griffin, and decorative compass roses. Geography is blended with symbolic icons like snowflakes for cold climates and cherry blossoms over Asia. Various sea vessels and sea monsters navigate the swirling, teal-colored oceans.
The picture depicts a modern chemistry laboratory where several students are conducting scientific experiments. In the foreground, students wearing white lab coats and safety goggles are carefully handling beakers and pipettes. The background features advanced technology, including digital displays showing 5G icons and complex data charts. Various colorful chemicals labeled as aqueous phase and organic phase are visible on the workbenches. Overall, the scene highlights a highly collaborative and technologically integrated educational environment.
The graph measures environmental health, cultural resonance, and magical potential for 6 distinct realms, including the celestial citadel and ancestral cradle. Magical potential reaches its highest peak in the celestial citadel with a score of 9.6. In contrast, the sand-sea domains show the lowest environmental health at 4.2. Each realm is paired with a real-world geographic inspiration, such as East Asia or Northern Europe.
The chart displays sector allocation for research funding, broken down into major scientific categories. Biomedical science and healthcare holds the largest share at 32%, including drug discovery and genomics. Other significant sectors include green energy at 22% and artificial intelligence at 18%. The outer rings provide granular detail, such as quantum computing and pandemic preparedness. Overall, the data highlights a major global focus on healthcare and sustainable technology initiatives.